Hello friend, welcome to Marine Engineering Hub. This is our narrator, Chief Engineer Ravi Gupta. Today we will talk about inert gas system. In today's video, we will try to understand what is the importance of having inert gas system in shipping. After that, we will see what is the marpol regulation which talks about the inert gas system. And then we will see through a diagram that how the inert gas system look like and what are the importance of each and every component. So we will discuss the important component of the inert gas system, and after that we will explain more detailed video about Dexil, PV breaker and PV valve in the upcoming section. So this is the first part of our inert gas system. So friends, those who want to know about this type of video, so please subscribe Marine Engineering Hub. Marine Engineering Hub make video like this which will be beneficial for examination, interview and for oral examination. So friend, let's start today's video of inert gas system. In today's video, let's first start why do we need a inert gas system. So basically, in order to reduce the risk of fire and explosion in the cargo hold, we need to have a inert gas system. Typically, this inert gas system is provided in tanker such as chemical tanker and oil tanker, because whenever we are doing loading and unloading, at that time we are dealing with the type of flammable cargo which can cause an explosion or a fire. So the first thing, if anybody asks you why we need the inert gas system, the answer should be like this: we need inert gas system because we need to prevent fire, because as we are dealing with the flammable cargo, there is chances of having a fire and explosion. In order to avoid that, we need inert gas system. What do the inert gas system do? Basically, the inert gas system inert the tank. What do you mean inerting? Inerting means reducing the oxygen level below the flammable limit. So that is the inerting. So we need inert gas system to prevent fire. Second is the cargo protection. How it is protecting the cargo? It is protecting the cargo by preventing it getting damaged from fire, explosion and other financial loss. Second is that it act as a safety enhancement. What do you mean by safety enhancement? Safety enhancement means that we are ensuring that the cargo is not getting exposed to the air, because sometimes some cargo, this is the inert gas system look like, sometimes some cargo in the cargo tank, suppose it's a cargo tank, in this cargo tank sometimes sub cargo if exposed to the air will get bad. In order to prevent that, we provide a layer of inert gas system. So it also acts as a safety enhancement. Fourth thing is that it is provided because we need to comply with the rules and regulations of marpol and SOLAS. So friend, what is the importance of having inert gas system? These are the 4 points. First, fire prevention. Second, safety enhancement. Third, cargo protection. And fourth, compliance with the regulation. So this is how you need to explain the importance. Now the inert gas system look like this in a ship. Now which marpol regulation talks about the inert gas system is basically regulation 13 of a marpol annex 1 talks about the inert gas system. So inert gas system is basically provided so that we can prevent any type of explosion or fire, because we are dealing with the flammable cargo in a tanker. The system is designed so that it can efficiently provide the inert gas for the inerting the tank. Now let us explain one by one all the system. So first I will explain how the whole system, how the gas is flowing, and second we will talk about the thing. So first you are seeing this is the boiler uptake. This is the boiler uptake valve. So basically, whenever during the combustion, the exhaust which is coming out from the boiler, the exhaust which is coming out from the boiler is basically having oxygen content less than 5%. So it means the oxygen content of the flue gas which is burned in a boiler is having oxygen content less than 5% is being taken through a valve and it is passed through a scrubber system. After the scrubber system, the system is passed through a blower. From blower, it is going through a pressure regulating valve to a Dexil. From Dexil through a non-return and deck isolating valve, it is going to a cargo isolating valve to a cargo tank. So this is the flow diagram. One more time I will tell you. In the upcoming slide I will explain each and every component important function. First let us try to understand the flow. From boiler uptake, it is going to a boiler uptake valve through a scrubber system. From scrubber system to a gas blower, the pressure is being increased. From blower outlet, it is going through a pressure regulating valve to a Dexil. From Dexil through a non-return and deck isolating valve, it is going to a cargo isolating valve through a cargo tank. The PV breaker and the Mast riser is provided for a different purpose. We will explain in a next slide. So this is how it look like. Now try to understand one by one. First thing. So first is the inert gas source. So what is the inert gas source? As I told you, the inert gas source is the boiler uptake. So the inert gas system which I am explaining here is taking the inert gas source from the boiler uptake. There is one more system which is called IGG, which is inert gas generator, that uses source the diesel as a source to produce the flue gas having oxygen less than 5%, which I will explain in the next video. So this is the inert gas system which is taking oxygen from the boiler uptake. From there it is passing through a scrubber tower through a isolating valve. So what is the importance of this isolating valve, if anybody asks you? So this valve, these two valves is having an importance that if we close these two valves, then this whole system will get isolated from this boiler uptake. Okay, so it means that if we don't want to use this scrubber system, then we can close these two valves and the whole system will be isolated. So that is the inert gas isolating valve and inert gas source. Now let's talk about the third most important component is the scrubber unit. In a IG system, in the examination they will ask about the four things. First is the scrubber unit, second is the Dexil, third is the PV breaker, fourth is the Mast riser, fifth is the PV valve, and if anybody want to know, they will also ask you the lower outlet valve. Now let's talk about the scrubbing tower. So the scrubber tower work is what? So scrubber tower work is to that the flue gas is coming like this. You see, the flue gas which is coming from here, from boiler uptake, is coming here. Now it is going flow and then it is going like this. So basically the gas from the boiler is coming here, and after that it is passing through this and then it is going here. Now while passing from here up, means from down to the upside, when it is passing, a scrubbing liquid is being sprayed to a packed bed. What do you mean by packed bed? Basically it consists of granules which reduce the flow rate, so that the exhaust gas which is coming here is getting clean, and second, the reaction with the scrubbing liquid. Now what is the scrubbing liquid? In a closed type scrubbing liquid, in a closed size system, we are using caustic soda and other chemicals to treat the exhaust, but in an open loop system we are using seawater. So basically the chloride, sodium chloride, calcium or limestone, these are the chemicals which are used to treat the sulfur which are present in the exhaust gas. So the function of a scrubbing tower is to clean the exhaust gas, and second, to reduce the SO2 level up to 90%. So if anybody asks you what is the function of a scrubber tower, the function of a scrubber tower is to clean the exhaust gas, and second, to decrease the sulfur dioxide which is consists of a exhaust gas. How it is doing? If anybody asks you how the sulfur dioxide is being reduced, so you tell them that if it is a closed loop system, in closed loop system it consists of limestone and other caustic soda material which will undergo a reaction in this packed bag, and after that it will remove with the reaction. But if it is an open loop system, in open loop system it will undergo reaction with the sodium chloride which consists in a seawater. What do I mean by open and closed? Is basically the water is been not recirculated in a open system, and if the same water is recirculated, then it's called closed loop system. So here we are talking about open loop system. The seawater is coming here, and the sodium chloride which consists in that, it undergoing the reaction. So from boiler uptake we come to isolating valve, and then in the scrubber tower the exhaust is clean and the sulfur dioxide is removed. Now the gas is clean, inert, is passing through this valve and going to a inert gas blower. One more thing you will see, this is called mist eliminator, also known as demister. So what is the function of demister? It consists of a basically polypropylene. It is made up of a polypropylene. The function is to eliminate and absorb the moisture which is consist in a treated flue gas. What do I mean by treated? Treated means removal of sulfur dioxide and soot, that is all treated. Now after that it passes a gas blower. The gas blower is basically can be steam driven or can be motor driven. Mostly you will find the motor driven. So the gas blower will increase the pressure, and from gas blower it is go to a pressure regulating valve. There's rules and regulation regarding the gas blower which says like that gas blower system, it says means if you have a gas blower 2, so it say the combining both the system number 1 and number 2, if both system is been run, in that case the system shall be capable of delivering the inert gas to a cargo tank and a slop tank at a rate of 125% of a maximum rate of a discharge capacity of a ship. So try to understand. Suppose the discharge capacity of a ship is 1000 meter cube per hour. So the discharge rate of a blower, should be 1250 meter cube per hour, combining both blower. So it say that if the discharge rate of a ship is 1000 meter cube per hour, the discharge rate of a blower should be 1250, combining both blower 1 and blower 2. Okay, that is say. Now in shipping, what the manufacturer do, that each blower is provided with a discharge capacity of 125%. It provide a redundancy. It means that first the regulations say about the both blower, but what the manufacturer do, they design each blower in such a way that individual blower can provide 125% of a discharge capacity. Now let's talk about the pressure regulating valve. So what is the importance of having this pressure regulating valve? The pressure regulating valve basically recirculate the excess gas back to the scrubber tower. Means if the gas is excess, they will recirculate back to the scrubber tower. Okay. Now after that we talk about Dexil. Now this is the Dexil. So the question is asked, why we need to have a Dexil on board. Now one more thing I want to tell you, this part is basically is normally inside the engine room, and this part from here onward, once if you see, if you can divide like this part is in the engine and this part is in the deck side. So from Dexil onward it will be on deck, and till blower it will be inside the engine room. Okay, so basically let's see now Dexil. What is the purpose of having Dexil? The Dexil we have provided on board to ensure that any gas which is been gone to the cargo tank area should not return back. So it means to stop the gas to return back which are coming from blower to a cargo tank. So now suppose this is the cargo tank area. Now any gas which has gone here, in order to prevent returning back to the blower side, to prevent that, this Dexil is provided. Now let's see how this Dexil work. So basically, as you can see, there is a water column, means the gas which is coming here, it getting inside the water column, and after that it is coming out from the water column and then going to the deck. One more time I will tell you. As you can see in the diagram, the gas is coming inside the water column, and after that the gas will come out from the water column and then it will go to the deck. So how it works? So as you can see, this here, the gas is coming from here, it getting out from the water column. This is a demister which remove any moisture content, and then it's going to a deck. So if any backflow happen, now suppose what I told you, that it prevent any cargo from the deck to come to the blower side. Now how it will work? Now suppose any cargo from the cargo line is coming back to a Dexil, so it will hit the water column, right? So it will hit the water column and water column will raise, water column level will raise. So as you can see right now, the water column is here, okay, here. Now when the cargo is hitting the water liquid, the column will increase, and it will go here. So as you can see, it is having a capillary action. So first, when the cargo is flowing from here to here, it is going like this. But if the cargo is coming back due to any back pressure, the water column is increasing and the cargo is not going to the blower side. So basically it is acting like a non-Newton system. So this is how the Dexil prevent any cargo to coming back to the blower side. So as you can see here, it's coming from here like this and it will go like this. Now second function of a Dexil is that it provide a tight seal between the blower deck and the cargo hold, and also block the air infiltration. It means that any type of air infiltration is been prevented by the Dexil, which help to protect any potential flammable atmosphere to generate. Now let's move forward. After Dexil, what we have? We have two non-Newton valve. One is the non-Newton valve which is provided, and one is the deck isolating valve. So what do I mean by deck isolating valve? Now suppose we are generating inert gas, and after generating inert gas, we don't want the inert gas to go to deck. So in that case, we can isolate the inert gas from deck by this valve. So this valve is provided, which is known as deck isolating valve, which main function is to isolate the whole deck from the inert gas. There is one pipeline is fitted here, one valve is there. So basically what it do, now suppose you are generating inert gas, but right now you don't want to send the inert gas to the cargo tank. So what you can do, you can open this valve and it will vent it to the atmosphere and it will not send the gas to the cargo tank. But when you are ready, in that case you can close this valve and you can open this deck isolating valve. So this is how it can work. After that, PV breaker. Now if anybody asks you why the PV breaker is being provided, so basically, now suppose the scenario, okay, now you have opened this deck isolating valve, okay, but you forget to open any cargo tank valve. It means that you are supplying cargo, you are supplying inert gas from here, and the inert gas is coming here in the pipeline, but these valves, suppose there is two tank in the ship and both valve is been closed. The inert gas is coming, and what it will do, it will pressurize the line. And suppose this vent riser is not enough to vent out, the mast is not enough to vent out the gas. In that case, it will pressurize the line. When the line is in pressurized, to prevent the over pressurization, this PV breaker is been provided, which will vent out the excess gas, acting as a relief valve. So this is the importance of having PV breaker. But this PV breaker is provided in a crude oil tanker, not in a chemical tanker. Now, second thing we'll talk about pressure vacuum valve. So pressure vacuum valve is provided in a individual tank. So one thing you should be clear that PV breaker is provided in a line of an inert gas system, mainly in the crude oil tanker. It will not be fitted in a chemical tanker, but PV valve is provided in an individual tank. What is the function of PV valve? We will have a detailed video in the upcoming section. For now on, I can tell you only that we are providing PV valve so that to ensure that we maintain a positive pressure in a cargo tank. It means that if the pressure in the cargo tank is increasing, we can vent it out through a PV valve, and if the pressure in the cargo tank is decreasing below the required criteria, to take the air inside the tank. It means that suppose this is a cargo tank. Now if we are taking any cargo, the pressure is increasing. In order to vent it out, we are venting it out to a PV valve, individual cargo hold. Now suppose we are loading and we are discharging, and there is a inert gas. Okay, now we are discharging and there is a drop in the pressure. In that case, what will happen? There will be a vacuum will be created. In order to avoid that, sometimes the PV vacuum valve will operate and it will take the gas in air inside the tank. But we should be careful to ensure that the air which is taken inside the tank do not get a flammable atmosphere. We'll talk about that in the upcoming video. So if anybody asks you what is the function of pressure vacuum valve, the function of pressure vacuum valve is to ensure that we maintain a positive pressure inside the cargo hold. They also vent out the excess pressure in the cargo hold, and it also take air inside the cargo hold if the vacuum condition is developed inside the cargo hold. It means that if a pressure inside the cargo hold is increasing too much beyond the limit, it will act as a relief valve and it will vent out the relieve the excess pressure. Now if the vacuum condition is being generated inside a cargo tank, to relieve it from there, from a certain point, it will also take air from the outer atmosphere. So it is a safety feature in a cargo hold system. Now let's talk about the cargo tank isolating valve. So what is the cargo tank isolating valve? This is the cargo tank isolating valve. So the main function of this cargo tank isolating valve is that if we don't want the inert gas to flow in that particular cargo hold, we can close that valve so that inert gas is not going in there. Now talk about the Mast riser. So basically what is happening at time of loading? At time of loading, what will happen? Too much pressure will be generated inside a cargo tank. Some will vent out from PV valve, and some will go through a line and it will go through a here, and from Mast riser it will vent out. So basically the Mast riser which is provided in the front, it will relieve the excess pressure of an inert gas at time of loading, and it is kept open so that to avoid the over pressurization of the cargo tank. So if anybody asks you why we need to have a Mast riser, so basically suppose you are loading the cargo tank. Now the cargo level was here, after some time it was here, and then it is here. So when the cargo tank level is increasing, slowly the inert gas padding which was filled, it will get increased. As the pressure will get increased, the excess pressure will be relieved from here to this to vent riser, and it will go out from here. Means the excess gas will come here, it will go here, and it will from here, it will come out. So in order to ensure preventing it from over pressurization, this vent Mast riser is provided in a PV breaker or PV line. So this is how the Mast riser work. Now friend, in my upcoming video I will make a detailed video about the PV breaker, Dexil, PV valve and Mast riser. So this is how the whole inert gas system work. The exhaust from the boiler after is coming here, from in the scrubber system it is getting clean, the sulfur dioxide is being reduced. From after that the inert gas blower is increasing the pressure, and after that through a pressure regulating valve, depending upon the demand, the gas will flow through a Dexil, and remaining gas will flow back to the scrubber tower. After that, the Dexil, acting as type of non-intern, is passed through a non-intern valve and the deck isolating valve. From deck isolating valve, it will pass through a cargo isolating valve and then to a cargo tank. Now, if there is overpressurization in the line, in that case, the PE breaker will act as a relief valve, and vent riser will come in the function at time of loading to prevent the overpressurization. So this is how the inert gas system look like in a simple way. Friends, if you like the today video, please do subscribe and please do share video with your friends. Thank you friend, have a good day. Those who are watching the video till now, for them I want to tell you that you have a demotion and you have a emotion that you want to pass the exam very quickly. So I request you, please join our channel. You can find the video which are yet to be released and which will be beneficial for your examination. The fees are very nominal, and the fees which I have kept is been used for a charitable trust purpose. So help us, grow with us. Thank you.